Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and in this short video we're going to concentrate, another video in our series of videos dealing with correlation and regression is going to concentrate on the calculation of the covariance, okay? I suppose we have a number of formulas that I've developed sort of in previous videos. We have the definition of the covariance, okay? You can actually see what it is. Here's the cross products, okay? It's as the x's vary from their mean and the y's vary from their mean. It's measuring that particular relationship, and don't forget the x's and y's are paired values, okay? So this particular product here is capturing as one variable varies with respect to its mean relative to the other variable varying with respect to its mean. In the previous videos, what we've done is we've taken this particular formula here and we've converted it into alternative forms just through simple transformations. In this form here, we're just looking at the means of the independent and the dependent variable, and also the mean of the cross product. And then we've converted this here then into a form where we've just got sigma notation, where it's the sums of the independent and the dependent variable and the sums of the cross products. Now, I'm going to just run a quick example here of how to calculate the covariance for a particular data set. So what I'm going to assume is I have an independent and I have a dependent variable, xy, let's say. And what I'd like to do is I'd like to calculate the covariance for a particular data set. Let's say the observations are 2, 8. Don't forget, these are paired observations. So when the independent variable is 2, the dependent variable is 8. Let's say, for argument's sake, that we have 4 and we have 5. Let's say we have 3 and we have 4. Let's say we have 5 and we have 2. And let's say we have 6 and we have 1. Okay, so there's my paired observations. And what I'd like to do is I'd like to calculate the covariance. Let's calculate it using this particular formula here. Calculate using this formula. What we need to calculate is we need to calculate for each observation, for each x observation, we need to calculate the distance it is away from its respective mean value, and for each y observation we need to calculate how far it is away from its expected mean values. So we need to calculate the mean values first of all. So let's just sum up the columns first of all. So let's say we have 2 plus 4 gives us 6. Here we have 9, we have 14. So this, the sum of this column here is 20. And let's say we sum up the next column. Okay, so the next column is 8 plus 5 is going to give us 13, plus 4 gives us 17, plus 2 is 19, plus 1, we have 20 here as well. Brilliant. Okay, so you can actually see now that that's the sum of the x's and the sum of the y's. That's the sum of the x's and the sum of the y's. So we have our x bar is simply going to be 2, 4, 5. It's going to be 20 over 5. So we have it's 4, and we have our y bar in this case here is also going to be equal to 20 over 5, which is going to be equal to 4. Okay? So what we can calculate now is our x minus our x bars, x minus x bar column. Okay, and we can calculate our y minus our y bar column. Okay, so our x minus our x bar. So for each x, we're going to take away 4. So 2 minus 4 gives me minus 2. 4 minus 4 gives me 0. 3 minus 4 gives me minus 1. 5 minus 4 gives me 1, and 6 minus 4 gives me 2. Okay, in the y case, it just happens in this case that the average of the x's and the y's is the same. It won't necessarily be like that. Okay, so we have to do our y's minus our y bar. So it's 8 minus 4 gives us 4, 5 minus 4 gives us 1, 4 minus 4 gives us 0, 2 minus 4 gives us minus 2, and 1 minus 4 gives us minus 3. Okay? So we've calculated this x minus the x bar and the y minus the y bar, but we need the cross products of them. We need this product, so we need to expand this table out, and we need to put in another column. This column is going to be our x minus our x bars times our y minus our y bars. Okay, so what does this look like? Well, it's the cross products. It's the x minus the x bar values times their respective y minus y bar. So you can see actually how the relationship of the change in the x's with respect to the means and the y's with respect to their means. You can see how the pairwise changes are now being captured through this particular product. Okay, so now we have minus 2 times 4 gives us minus 8. 0 times 1 gives us 0. Minus 1 times 0 gives us 0. 1 times minus 2 gives us minus 2. And 2 times minus 3 gives us minus 6. So now we end up with, if we sum up this column here, which will be the sum of the x minus the x bar times the y minus the y bars. So we have minus 8 plus minus 2 gives us minus 10. plus minus 6 gives us minus. So what we got here, we have minus 16. Okay, this value here is the sum of the x minus the x bars times the y minus the y bars. Okay, so now from our formula, our covariance of xy, okay, we end up with, it's the sum of the x minus the x bars times the y minus the y bars, which is minus 16, okay, which needs to be divided by n minus 1. N is the number of paired observations that we have. So we've got 1, 2, 3, 4, 5. So n is equal to 5 in this case, okay, so this needs to be divided by 5 minus 1, so divided by 4, which gives us a value of minus 4. So the covariance is minus 4. The important thing here is that the covariance is telling us the directionality of the relationship. So what it's saying is that there's a negative association between the